I don't know when it was. Welcome back, everybody. Yes, about me talking over you, but you're good because now you're not, so you're good. Okay, cool. All right, we're talking about parallelograms, and we switched gears. Instead of saying if it's a parallelogram, then this is true. What are we doing now? If this is true, then it's a parallelogram. So we have seen a few of those theorems already, and here they are. We just named them. I just named them all the tests, but these are just all the converses. If you give me any foregone and the opposite sides are congruent, then it's parallelogram. We saw that one yesterday. Then we did what with it? What is all this indicative of? Hey, we proved it. Cool. And then we said we didn't prove this one, but if the angles of a foregone, the opposite angles, both pairs are congruent, then it must have been a parallelogram. We went a step further and said, hey, if you give me any two consecutive angles, of this and their supplementary, then we have a parallelogram. And that was the last theorem that we wrote yesterday. Now, on number 17 or 9, whichever one, this was my hint that I gave you, I remember. Did this help on number 17 for those of you that did it? Okay, if you didn't get to 17 yet, I do want to stress, this was the hint that I gave for number 17. And what is this again? Oh, it's for this one. Oh, okay. It was for this one. Oh, because I asked you guys to also think about that, huh? Okay. So we'll come in here. I'm going to keep that homework there because I'm just going to add to it now. We only have a little tiny bit. I'm going to make a claim, and part of the fun part is if I make a mathy claim, my guess is you guys will probably believe me. Like, believe. Like, you should. I don't get up here and teach you the wrong thing. That would be outrageous. You guys ever seen the movie Kung Pao? Okay. Have you really? Kung Pao Enter the Fist? Yep, in the old Chinese movie? Okay. So I'll make a. It's stupid funny. All right. We're not going to go into that. Anyway, check it out. I have a claim, and I want you guys to tell me, one, is this true? Probably, just throwing it out there. But I want you to convince me why it's true, which is me asking you to do what without saying it? Prove it. Now, here's the deal. I don't need necessarily on this, just in our notes, I don't need a super formal proof. I don't need A, B, C. But what I care more about than the ability to do A and B and C is the what that builds our proofs. I need the logic, right? Like, it's easier to get the logic than to formalize it into that 2-column proof. The 2-column part, like, it's important, especially if you're going to be doing proofs of stuff, because that will like develop into further, more advanced techniques. But I care much more about your mathematical logic than I do about your ability to do very specific 2-column proofs. So I'm concerned with the logic here. Our last theorem for right now, anyway. Are we at 15? We're at 14? We're at 14. Oh, yeah. Well, I missed 2, so we get 2 theorems right off the bat. This one, we're going to do it with both of them. So these are all tests, is what we're looking at. These are tests for parallelograms. 14, this is test 4, right? Yeah. Okay. You're good. Okay. So I'll go, just kidding. As we're looking at it, test 4, here's what I'm going to claim. We look at all those old theorems. I'm going to write it out, and then you guys are going to help me sketch a picture and see if we can't logic it out. If the diagonals of a foregone, and what do you think we're about to say these do to each other? Bisect one another. And you could simply say each other if you would rather. If you give me a foregone and it turns out that both diagonals bisect one another, conclusion? Probably going to be a parallelogram, right? We're looking at all these converse statements. So if the diagonals of a foregone bisect one another, then, and I'm going to write kind of cave person style, parallelogram. Now, the real phrase should say, then that foregone is a parallelogram, right? Is that meaning implied here? Okay. Well, I'm going to draw a parallelogram. And just to make sure we all get the same pieces to like speak about it with, I'm not really drawing a parallelogram. I'm drawing something that's believably a parallelogram. All I know right now is it's a foregone. So let's stick to that convention from yesterday. And we'll call this foregone quad for quadrilateral. If I wanted, and I'm going to give you guys a second because I always do too fast here. I want us to prove that, right? Like that's the goal. Now, logically or formally, if you want to do it formally for practice, I'm good with it. It's not going to hurt you. But if I want this, I don't have enough in my picture yet. What else must I add to this picture to be able to even start thinking about the logic that goes into this? The diagonals. Now, it's super silly, but I don't even remember what that means. I need a couple segments, I think. What's one of the segments that I might add in here that's a diagonal? QA, quantitative analysis. You got it. Any others? UD. Awesome. And any other marks that I should put based on this? So they intersect, and we can call this R, since that's a next natural part. But I think there's, like, that's a good call. That was not what I was expecting to say, but you guys are right. What did the diagonals do to each other, we're claiming? So how would I mark that they bisected? Not a dot. Dashes. What's the same as UR? UR and RD. They have to be the same. What's the same as QR? And RA. This is all of our given information on the picture. Now, we just didn't formally write it down, right? If we were doing a formal proof, part A would be foregone with UR congruent to RD, but it's marked here. Okay, I don't need the formal ABC unless you really want the practice with it. I might do the formal up here, we'll see. But what I am gonna do is I'm gonna give you 3 minutes, talk with your neighbors. I want the logic. I'm not asking for a formal proof unless you really want it. Convince me that just this information is sufficient to say that this is a parallelogram. 3 minutes. I want to hear you guys talking. If you're stuck and you have no idea what to do, you have two options. You can either ask me or check this out. Let's say Sunny and Gian have no clue. Who else could they possibly talk to without causing a huge ruckus? So regardless of the fact that Elijah's sitting behind and seemingly everybody realizes Elijah's pretty good at geometry, the people behind them is the part, right? Just like if you two are struggling, you can bounce ideas off the two behind you and vice versa. Like, as long as you guys are talking about the math, I'm good with it. Cool, cool? Okay, I actually think it's going to be 4 minutes, unless, anybody see the other hourglass? I think I knocked it down sometime. Where's the hourglass? You got me good. All right. Hey, when this one's done, I'm going to call on several random people to help me build the logic, so be prepared because it might be you. Go. Talk it out. How? What?
Okay. We know because this is vertical, right? So
Okay.
we know that we can draw that out. We can mark that, right? Let's mark the vertical.
Okay.
We already have what side equals side.
Okay.
Yeah.
All you've shown me is the triangles are the same.
Right. That means the parallel.
What?
Right. And they bisect. If these are the same, if UR is the same as RD, you know, that is just we can add lines. No, we can't assume so.
So I'm going to tell you, no, but you are so close. You're on the right track. Your first step is good. I like your angles.
So vertical angles,
Okay.
side angle side,
Okay.
CPCTC, and then opposite sides of the
There it is. Okay, here's the deal. You're not just going to say, here's the answer. You're going to shove people, though. I want both you guys to stand up, and you're going to chat with other people who are struggling. You're my helpers right now. Yes.
Right.
What are you guys thinking? So you are proving it, and I don't care. Like, we are proving it. Just to be clear, I'm just not making you do it really formally. If we're doing it, if it were a formal proof, we always go through and mark anything that we know for sure, right? Is there anything here on this shape that you guarantee is the same as another piece of it? So right, but that's already marked, right? So we can't mark them parallel yet. However, no, because you can't say that it is parallel to show it's a parallelogram. But what we can do is foregons can be hard to think about. Can I steal your pencil real quick? I want you to look very closely at these two. And then whatever we say, like let's say I asked you instead to show these were the same. Do you think you could? So there's an angle on those that I think we could look at and use. What are you guys thinking?
That U and Q could be like parallelogram to U and V.
So that's what we're trying to get to. I agree. The issue, and people, you're not the only person that's doing this. This is really common. You're trying to say they're parallel to show they're parallel. Do you understand how that feels like wonky? It's like same thing, and this is my go-to example. If I needed $10 and I gave you a $10 bill to borrow $10, like you'd be like, what's the point? Like, and it's the same thing, but check this out. Foregons can be hard to think about. What's easier than a foregon? Two guns don't exist. A three-gon. Give me the real name for it. Yeah. Are there triangles up here? So you say no, Jonah, but there's a bunch of them. At least 4, because there's a couple other big ones. Could you show that triangle URA, the top one, and the bottom one are the same? How? Yeah, like how would you convince me that that triangle URA, the very top one, this is the same as this? Yeah, I think they are congruent, but there's only one thing that even if I don't ask you to do that, just looking at the cross, are there any angles that you guarantee are the same? Starts with a V. Are there vertical angles on this picture? Here and here? Mark those angles, the vertical pairs, as congruent, and then look at those 4 triangles and compare them.
Okay, I was just thinking like the triangles and
Mhm.
stuff, and how like SAS and all those things.
Agree?
So would that be side angle side, because this would be a vertical angle?
If you show me the angle that you're marking, like,
Or like
and you should mark them real quick. Like, might as well just do it.
this. Oh,
So that one is the same as which one?
this one.
So I now know that this triangle and this triangle are the same, right?
Yeah,
And is the same going to happen here?
yeah.
Okay. Now, here's where people get goofed up on this. Every time we get a new theorem, it's like we're just adding another tool into our bag, right?
Yeah.
If before we had a hammer and then we got a screwdriver, I'm not going to use the hammer to put the screws in. I'm going to use the screwdriver.
Yeah.
Do we have another theorem? Like, if these are the same, would you agree that this and this are the same?
Yeah.
They're corresponding parts.
Yeah.
So these are the same. Are these also the same?
Yeah.
And what did we say yesterday about a foregon that has both pairs of opposite sides the same?
Parallelogram.
And there we are. Like, we have that tool that we developed yesterday. Let's use that tool today. My clock took away the time. I used to have a second timer on the clock, and now it's gone. And it drives me crazy. Okay, we're going to come back together. I'm going to let you finish your thoughts in 5, 4, 3, 2. Yeah, we went longer. 1. Okay, this question can be kind of tricky at first. Here's what I really want to emphasize. Have we had some other theorems this chapter already? Yeah, for sure. Now, I like the analogies, so I'm going to try to clean up the one that I used with you guys. Let's say that we were trying to build a house and we had some screws and nails, and then one day we found a hammer, and I'm going to use a hammer to pound in the nails, right? And then the next day I find a screwdriver, and I'm going to use the screwdriver to screw in the screws. If I come back the next day and I have a screw, am I going to hammer it in? No, I'm going to use the what? Screwdriver, because we worked with that tool the day before, right? Now, theorems work exactly the same way. Every time we get a new theorem, we're just adding a newer, better, stronger tool into our toolbox here. If we have a way to get to any of the other test theorems that we saw yesterday, then we should be okay. Do you guys agree that there's at least 4 triangles on the board? Now, if I look at just the top triangle, URA, and just the bottom triangle, QRD, can you convince me that they are congruent triangles? How? I'd mark the verticals, and then I'll use side angle side. You're right. Okay. Now, if I mark just the vertical angles, and even if I don't know what to do with the proof, I think that that is a reasonable first thing. We've made it pretty commonplace to just go down to triangles to deal with them. Vertical angles are congruent. This and this, and this and this. So even if I didn't know where to go in this proof, I do think this is a reasonable first thought. Now, once I do this, I do get side angle side. QRD, this bottom triangle, matches with which one? And give me the name of the top one. ARU, right? So as I'm looking at this, is QD corresponding to another part of the other triangle? QD corresponds to what? And if there's triangles are congruent, then what do we say about these two? So I'm going to use blue instead of green just so I don't have to use all the wonky dashes. Do we agree that because those triangles are congruent, that's true? Is this triangle congruent to this triangle? By what reason? Side, angle, side. It's the same thing, which means corresponding parts will allow me to get to this UQ being the same as what? AD or DA. I'm okay with either. Do we agree that we can get there? Now, if only we said something like right now, if I look, forget about the diagonals. Do I have a foregone? What do you notice is true about the opposite sides of this foregone? They are congruent. And if both pairs of opposite sides of a foregone are congruent to one another, then, bless you. So what do we just guarantee this was? Parallelogram. Now, we just did the proof, right? We just didn't formally write it down. Do you want to formally write it down for practice? Okay, so some of you say yes, sorry. Some of you say no. Here's the deal. I make you guys take notes, just for the record. Like, I do want you guys all taking notes. Do I come around and check to see that you're writing word for word what I do, Sevilla? Not typically, which means if you don't need the practice with the proof, do you have to write it down? No, but do I need you paying attention, at least thinking about it a little bit more? Let's formalize this process real quick. So looking at this, we have it all done, and I can erase marks if you want, but every proof ever starts with what? What were we given in this? So I'm going to write that out to what I marked. UR was congruent to DR, and what else? UR was the same as DR, and QR is congruent to RA. Okay, and why am I allowed to write that? It's given. Now, we get a choice here, and I don't know that I will do this next year. I haven't decided. Do you guys like naming these with numbers instead? For some of you, it probably takes away from it. If you want to, I have no issue, and I actually prefer it myself, but I'm not the person learning this. 1, 2, 3, 4 makes it easier to talk about these angles. It gets gross when we talk about these letters, but I'm going to use the letters this time. If you want to do 1, 2, 3, 4 and just make sure it matches, I'm okay with that. So check it out. I know then that we get a couple pairs of congruent angles. Angle URQ, angle URQ, and that looks like from U to R to Q, it'd be these ones right here. What's URQ congruent to? ARD, angle ARD. Now, what's my justification here? How do I know that that angle in red is congruent to that angle in red? They're vertical. Yeah, they're always congruent. Now, I could use another step, and I could call it C here. Or do I have another pair of angles that I'm going to say are the same because they're vertical angles? You are a what? Awesome person. Thank you. Okay. See what I did there? You are, okay, maybe not. All right. Guess not. URA congruent to what? QRD. And why? Yeah, and notice, I'm not going to write C and C vertical again. I'm just going to keep it here in this justification. At this point, where did we go? We use side angle side, right? We're looking at the triangles now. And we've really been looking at the triangles all along. But if you didn't notice it before and you just started here, my hope is that you'll look at it and recognize we do have some triangles that are the same. So let's write these statements. Triangle URQ, we'll start with that one, is congruent. That's URQ, that's this one. What's that congruent to? I disagree with DRA, has to be. Why is the order different? Dashes, right? URQ goes across 1 and then across 2. If we want to go across 1 and then across 2, we got to go DRA. Why are those triangles congruent? Side, angle, side. Now, I have another pair of angles that we're going to talk, or triangles, I'm sorry, that we're going to talk about. Correct. Is it also side, angle, side? So I'm not going to make another justification. We'll just go ahead and include it. It's the same justify. Triangle URA is congruent to which triangle? URA and DRQ. Is it URA? Yep, I agree. Triangle DRQ. Now, the whole point of recognizing using these triangles, remember, is so that we have access to the tool that we developed yesterday. Are there corresponding parts of congruent triangles? So SAS, and you can always ask here, that doesn't bother me. What's SAS stand for? Side, angle, side. And it's one of our shortcuts for congruence. Okay, why did we show these triangles were congruent? So yes, but how it's not just the triangles that we're going to use. Like we use them to get to our next statement. UA matches up according to our congruent statement with what? UA and DQ. Now I'm going to add the marks in red. That's these marks right here. And there's another one. UQ, U to Q matches up with D to A. So UQ is congruent to DA and Y. Because corresponding parts of congruent triangles are congruent, CP, C, TC. Now we're almost there. And I don't really like to reference test 1, test 2, test 3 because I don't remember the order that they come in. Same as I never reference theorem 6.7 because I don't know what it is. I just have a few simple phrases. Now, we used, I don't know which test, I think it was test 3. But can I now conclude that it is a parallelogram? Okay, and then I want you guys to help me, rather than justifying with a theorem and some particular number, how would you justify with just a couple words or a short phrase? Instead of writing test whatever because the order is irrelevant, how did we know it was a parallelogram? Opposite sides what? Can we write that shorthand so that everybody would understand what we're doing? How would you say opposite if you're trying to be lazy? Op, sides is reasonably short. Congruent. Now, if you really wanted to be super formal, you could go through and call it theorem 6 point whatever. I'm never going to know, and please don't do it on a test because I don't want to have to get out the book and look and see what number you're referring to. I would prefer a short phrase here. I can end this proof and show the reader that I'm done with this proof by putting a box with a square, or anybody but Elijah, I can write QED, which stands for what? You're close. Quad, which quad, that's fun that worked out that way. Erat demonstrandum. All right. Quad erat demonstrandum. We done. Okay. The formal proof, and maybe I just got a little bit better at doing this for next year. If we go through it really informally first, did that make that easier? For some of you, yes. For some of you, did it make it harder for anybody? Good. All right. There's one more theorem that we get, and we're nearly done. This is a super theorem-y chapter. Before we move on, let me go back to this one. Any questions that you have about this? So if I give you guys a problem where the diagonals bisect one another, everybody's going to be able to deal with it. Okay. Last one. I want you to tell me, I'm going to make a claim, and just convince me it's true. Logically convince me it's true. Don't need a formal proof. Last theorem that we get, and I actually gave third hour their homework, and I forgot to give them this theorem. So you guys are lucky here. What's our number? 6.15? Now this one, instead of just calling test 5, I'm going to call this our short test. Now again, please don't reference short tests on, like, if you're doing a proof. Just give me the basic idea. I'm going to make a claim here, and I want you guys to convince me it's true. I'm only going to draw this, and I'm going to make you guys help me write the theorem, but I'm going to give us the picture. I'll tell you, it shouldn't come as a surprise. What do you think the conclusion of this is going to be? It's a parallelogram. So I'll even tell you where I need us to end up. So here's this. It doesn't really look like it. That one looks different to that, but that's okay. So here's my claim. I think that right now, if I give you these, do you 100% guarantee that what I've given you at this point in time is a parallelogram? No. I don't think so. It kind of looks like it could be, but maybe I'm just a really bad artist, and AD shouldn't really look like this. It could have been a trapezoid, and I just suck at drawing. Now, I won't trap you like that. No pun intended there. Unintentionally. It was awesome. I wish I'd meant it. I won't trick you if it's a trapezoid or not, but it's possible that these aren't parallel, right? So I could give you these sides, and then it's just an elementary problem. There's nothing to do. It's just a parallelogram by definition. Here's my claim. I think that if I do this, I think I am confident in parallelogram. Why is my question. How on earth do I take this and say with confidence that this is enough, that it's a parallelogram? You guys are going to play around with this. My suggestion, what's easier to think about than a four-gon? Maybe three-gons, triangles might be helpful in this. I'm going to give you guys a couple minutes, and then we're going to bounce around randomly to try to logic our way through. Talk it out. Be prepared to get called on. If you have no idea what to do, I do, and I can probably give you some direction. Cool. Talk it out. Get loud. Get crazy. Talk about the math. I'm going to show you my very most favorite error in logic that shows up everywhere. I saw multiple groups doing this, and I love the idea. It's a good attempt, but I want to make sure we can all see this really common error in proving stuff. Okay. As I was coming around looking, you guys all added stuff to your picture. What did you add? The diagonals. Okay, check it out. Do not copy my picture right now if you're just copying it. I'm going to show you the most common mistake people make. It is natural to want to put both diagonals in. Totally reasonable. Not what I'm going to do in the end, but it's natural. Like, I get this. And then here's where the error in logic happens. People look at this and they say, wait a second, if it's a parallelogram, what do these diagonals do? And people naturally do this. Again, I want to stress, do not copy what I'm doing right now. My issue, my error has already happened. We just assumed it was a what to mark those diagonals the same. And we're trying to show it's a... Can we assume that it is what it is to show what it is? That doesn't make sense. That's that situation where if I need $20, I just give you a $20 bill and say, can I borrow $20? That's like, nothing happens. Nothing is moved. So here's my advice. Do less. Let's stop here. I just want one diagonal. And like, you're looking at it like, maybe no, I don't. I want two. Maybe you could probably do it with two, but I'm going to suggest this is faster. Do I have parallel lines right now? These parallel lines, are they cut by a transversal? And when I have parallel lines cut by a transversal, do I get some free angles? What angles are the same using right letters, the correct letters? You can't just say Q because Q's been broken into two, right? So Q1, Q2 doesn't work either. Like, I'm going to label them with numbers real quick so that we don't have to like skirt around this idea. I think there's 4 angles that I care about that just formed. Which ones are the same? Why are 1 and 3 the same? Be very careful though, because check this out. I know that the red lines are parallel, right? Do I know that the blue lines are? So I don't think I can use the blue lines are parallel to show that 1 and 3 are the same. But I know that 2 and 4 are, because these are my parallel lines cut by this transversal. Like, these other pieces are not part of this nice angle pair. That's all that I need right there. But with that, I think I can confidently say, instead of 3 and 4, AQD is the same as QAU. Everybody still on board with that? How many triangles did we cut this foregon into? Is there a side that's common on both of them? So those are congruent. How about in common? AQ or QA? At this point, each triangle has how many sides marked? Is it the included angle? Side angle side says these are congruent. Because these are congruent, what do I know UQ and AD must also be? And now, check it out, just like the last one, do I have a foregon on the board? And are both pairs of opposite sides congruent? Therefore, parallelogram. So to be able to write this out, help me write this theorem. I want to say that information is enough to make a parallelogram and to be confident of it. How do I make this a theorem? If, and I'm going to clean this part up first just so it's easier, one pair of opposite sides is all that we have to focus on. And what do we have to be given about that one pair of opposite sides? If they are parallel and congruent. And real quick, just if I haven't mentioned it, what does this thing mean? And how about this one? Or on that one. If one pair of opposite sides are parallel and congruent, then what? Then it's a parallelogram. And we did not do the formal proof, and in the interest of time, I'm going to suggest we don't do the formal proof. If you want to come in and do it, I will work through this proof with you, but we just logicked our whole way through it. It would just be writing down that logic. Okay, for the next 10 minutes, which is what we have left, two things. I'm going to give you a little bit of time to work on your assignment and just finish it. I'm not going to give you I'm going to give you some new problems, but nothing crazy. So everybody should have enough time to go from 2:45 to 5 to come into Mr. Holloway's classroom and play chess. Beyond that, though, I want to be very clear. I don't think that anybody in here is a flibbertigibbet. This is a real word, just for the record, a flibbertigibbet. Anybody ever seen this word?
Yes.
Was it in Gravity Falls? Okay, because that's the other one that I've heard. I've only watched like 3 or 4 episodes. It's a little bit too old for Zeke. A flibbertigibbet is a real word. A fool. It's a really fun way to call somebody a fool. Nobody's going to be calling another one in here a flibbertigibbet, though. Although I don't hate it because it doesn't feel that mean, honestly. It feels sillier than mean. Okay, with that, you guys, I'm just going to go back to the assignment from yesterday, and it might already be gone. I mean, every word is made up, right? Okay, you're going to add to this assignment that hopefully you already have those 4 done. You are going to add 18 through 21. Super short. Now, super short if you understand it. I do want to remind you, how many times this year do I want you to stay up in your bed at 2 a.m. crying because the math is too stressful? Literally 0. Which means if you are doing this assignment and you're at home and you're to the point of tears because you don't know how to do it, what should you do? You should stop doing it, first of all. Just come talk to me on Monday. I'd rather you understand the math and be successful with it than sit at home crying and learning that you hate something that you really shouldn't hate. Cool. We have 7 minutes. If you only have 3 problems left, you legitimately might finish. Cool. Jonah,